Okay, so now it's time to see and time to check how to create experiments in order to evaluate the different scenarios. So in this case, we're going to work with an example where we have a gas bottle, which is first welded, and then there should be controlled with X-rays in order to check that there is no leakage in the gas bottle. So this example is pretty simple, and we are going to start modeling it in SIMIO, first adding a source, and then adding a server, then adding a second server, and then adding a sink. Perfect. So the first server is related to the welding operation, and we call it welding. So we write welding here. Server number 2 is related to the X-ray operation, so we call it X-raying. And then we add a model entity, which is the gas bottle that we are producing. So we add it here on the top of source 1, and we write gas bottle. Okay, so something that remains to be done is to add the path between the source, the welding activity, the X-ray, and the sink. So we scroll down in the standard library, and we click on path, we click twice, and we connect the output of source 1 to the input of the welding, the output of welding to the input of X-raying, the output of X-raying to the input of the sink. And we have a pretty decent model now. So something we can do is to, for instance, improve the visualization of the model and to improve the aesthetic appealing of it. So we can add symbols both to the gas bottle and also to the activities, the welding and X-raying. So if we click on gas bottle, we can go up here and apply a symbol. And luckily we have many symbols, and the gas bottle by chance is available in the standard library provided by SIMIO. So we click here, and we have this yellow gas bottle to be added to our model. So we can resize it, and you see it's possible to see the bottle only from the top view at this point. For the welding, we can also apply a symbol and change the visual look of this server. So we click on welding, we click on apply symbol again, we scroll down, and we are pretty lucky because there is a welder, surprise, inside SIMIO that we can add as a symbol. So we click on welder, and we have a welding machine now. We have an X-ray machine as well. We click on it, we apply a symbol, and luckily just on the right hand side of the welder we have an X-ray that we can add. So we can have a view from a 3D perspective of how the process looks like. So we have a gas bottle, we have the welder, we have an X-ray machine, and we have a sink. Anyway, I prefer to work from a two-dimensional perspective. So now we need to input some parameters into the model. So for the welding operation, we observed that the processing time is more or less 2 minutes long, and we have a minimum of 1 and a maximum of 3 minutes. So we can change this in the process logic for the welding server, and we can essentially write 1, 2, and 3 in the processing time. So we write processing time of 1 minute as minimum, processing time as 2 as average, and 3 as maximum. So now we can also change the input of the source. In our network, in the previous activities that we have in the manufacturing process, we understand the inter-arrival time for the gas bottle to be around 2 minutes. So we can change it also in the system. And in this case, we have a random exponential distribution expressing the inter-arrival time. At present, it's 0.25 minutes, but the correct value is 2. So now it's time to have a look at the X-ray machine. So the whole intention of this simulation model is to evaluate 2 different machines that we want to buy in order to improve our manufacturing process. So if you look at the processing time for the X-ray machine, this is set by default as random triangular and in minutes. So our idea is in fact to simulate 2 different X-rays machines with different performances. So one way to do it is to first insert the performances of the first X-rays machine here, run the model, get the result, then change the parameter, run the model and get another result. Or we can use an experiment in order to do that. So how do you set up an experiment, and how do you signal to SIMIO that this variable is something you would like to modify in order to understand the performances of a process in a better way? So in order to create a property to be used in an experiment, SIMIO provides a pretty intuitive way. So what we want to test now are two different X-rays machines with different processing times. So we use processing time as a property to be varied, to be changed in the experiment. In order to create the experiment, then we have to right click on the processing time, and what we want to create is a new reference property. So you right click with the mouse, you get this small window where you have to select set reference property, and then down here you want to create a new reference property exactly for this purpose, to vary the processing time. So we click here. We get another pop-up window where we are suggested a name for the property. So I think this name is quite nice, and I will keep it. So I click OK. So now you see a small green arrow has appeared here just on the left-hand side of X-ray processing time. This means that we don't have exact value, but we can modify the value inside an experiment. In order to do that, we have to create the experiment explicitly. In order to create a new experiment in SIMIO, it is also a very simple process. You need to go up here in the navigation panel. This is one of the ways you can do that anyway. And go on model, right click on model with your mouse, and related to this model, you can create a new experiment. So the experiment is where you define the different scenarios and such. So we click on new experiment now. And when we click on new experiment, we enter a new environment, which is essentially designed as a table. So this table comprises several different columns already. So we have a scenario column where we have the scenario name and the scenario status. We have a column related to the replications that we want. This is the number of times the simulation model will run before rendering a result. Also, you have an indication of how many are completed, because I know simulating different scenarios might take some time. And here we find again the reference property that we defined before. This is a control to our experiment. So we can test different random dot triangular options in terms of processing time for our machine. So the first machine, the first X-rays machine that we would like to test has a minimum processing time of 3 minutes, an average processing time of 4 minutes, and a maximum of 5. Very simply. Okay, this is the first machine. So we want to test also another machine, which is slightly more unpredictable. So we have this machine which has a random. As you see, as soon as I write inside this box, a new scenario appears. So this has a random dot triangular distribution with a minimum of 1 minute, an average of 4, and a maximum of 7 minutes. Sorry, I wrote wrong, and a message appears all the time you do something wrong, so it's quite easy to fix. So in this case, we want to test 2 scenarios, and we require SIMIO to run 10 different replications of the same scenario in order to get statistically significant results. Okay, so the controls are here, and we have processing time, and the units are in minutes because were defined before in the model. Now we need to have a response. The response is basically the key performance indicator of the process that we are interested in investigating. So we are interested in investigating 2 things in this case. We want to know the average time it takes for these bottles to be welded and X-rayed. How much time does it take on average to go through the entire process? And we also want to know the maximum time it takes to go through the process. And this is because some bottles may take much more time than a random bottle. So we add a response then. So in order to add a key performance indicator and to get an answer to the question that we asked just now, we need to add this response, and we have to click up here on the left hand side of the screen on the top. So we add a new response, and this is called by default response number 1. So we can change the name of the response, and I think this is very useful all the time, because when the response become many, it's very difficult to navigate and understand what's going on. So here I want to know the time in system for the gas bottle, and I just want to know the time, I want to know the average time it takes for a bottle to go from the source to the sink. So I write time in system average. Okay, when I want to add another response, the maximum time in system. So I go here and I add another response. This is called response number 2. And the name in this case will be time in system max. Time in system max. Very good. So right now, these are blank. We didn't run the simulation, but we didn't even define what are we measuring. We have to communicate to SIMIO what exactly we are trying to measure in this case. So I click here on the first one on time in system average, and I need to add an expression. So the expression is the place where I communicate to SIMIO what I want to measure. So down here you have a sort of blank rectangle where you can write an expression. Of course, keeping in mind all the possible expressions for all possible experiments is kind of impossible. You cannot keep them. Maybe you can create an Excel file with a lot of different expressions and do copy and paste, but this is very time consuming. So one option that SIMIO gives you is the opportunity to browse possible ways to create expressions for your model. So try to follow me here. The logic is pretty simple, but sometimes you need to do a little bit of trial and error to find the right expression. So here on the right hand side you have a small icon with an arrow pointing downwards. We click here and we get a new panel. So the new panel that we get, it contains essentially all the stuff that we put in the facility view. We have the source, we have the sink, we have the welding server, we have the X-ray server, and so on and so on. We have the opportunity to add some math as well, and we have all the inputs and output nodes and the paths. So here you find everything that is contained inside the model. Starting from here, you have to define a reasonable expression for actually getting the average time in system, and how you do that. So it takes a little bit of time, and I think it's better you read the introductory guide for SIMIO in order to understand the logic, but try to follow me here as I said before. So a good place to start for looking at the time it takes to go from the source to the sink is probably the sink. So the sink is the place where we essentially register when an entity go outside the system, exit the system. So what I will try to do now is to double click on sink and define the first part of my expression. So I say, okay, I'm looking for this property, and this property is very likely to be here, to be at the sink. So in order to see what are the options in relation to what we can measure at the sink, you have to press the dot. And when you press the dot, you are presented with different types of parameters that you can measure. And luckily, we have a parameter that is called time in system. So I think this is exactly what we want to measure. So you double click on time in system. And right now, you didn't say anything about what time, what kind of time are you measuring. Is the average, the maximum, or no, the minimum, or so on and so on. So here you can in fact press dot again, and you are presented with more options. Now the options are in bold. When an option is in bold, it means that once you click, this expression is ready to be run inside the model. If it's not in bold, you have to click on dot and find out the end of that particular expression, because otherwise it's not recognized by SIMIO as a valid expression to run an experiment. So in this case, I want to know the average time. So I click on average. So now, since average was bold, this expression is valid. It's totally legit for an experiment, and I will run with it. So I click here on this green thick, and I define this expression for the first response. I can repeat the process for the second response. So I go on time in system max, I go to expression, I click here on this small arrow, and in this case I'm still interested in knowing, okay, what's happening at the sink. So I double click on sink, I click on dot, I can look at the timing system and double click on it, click on dot, and then I get to this window where I can select maximum in this case. So I click on maximum, I click on the green tick, and I sort of prepared most of my experiment. I think I will run with the number of required replications. I think 10 is a good trade-off between having too many and having too little. And I think we're ready to go. No, in fact, we are not ready to go. We need to do yet another thing, because otherwise we get very inconsistent results. So if we click on timing system here, we can see that the expression is probably correct. The problem is that we didn't specify the unit type. So we are expecting results in minutes, but we haven't specified even what type of unit we are basically measuring. The expression knows that this is a time that we are measuring, but still is better to be precise. So here we go under unit time, and we can select the type of time that we want. So the time is by default in hours, and this could become quite confusing in fact. So we change from hours to minutes for timing system number 1, and we do the same for the second one. And we can change again in time, and we get minutes as a response. We can very much set an objective too. In this case, we can select an objective, which is to minimize the timing system. Anyway, in this particular case, we have just 2 scenarios. This is very easy to find out which one is the lowest, the one that minimizes the timing system. But with many scenarios, this could be quite a nice feature to have. So let's run the model now and see what happens. So we run the model, and we find out that the average timing system is quite long, because essentially there's a lot of queue building up. The line is not very balanced. Anyway, it seems like the random dot triangular distribution, the first one that you see here on the screen, works better than the second machine, which is a little more unpredictable, both in terms of average timing system and both also in terms of timing system maximum, which is pretty similar in fact. So in this case we find out that machine number 1 is probably the one that we should buy for our process, because it's the one that provides the best performances. So we go back to the model now, and in the facility view I can essentially also tell you that I didn't show it very clearly, but I modified the initial capacity to be 2 for the X-ray machine, as I said in the beginning. So in this case we can also animate the model like this, and if we go under run, we can improve the speed factor as well. We go to like 8, and we are probably going to see that quite a lot of queue is building up at the welding station and also at the X-ray station sometimes. This is something that will adapt to the average and maximum time a bottle stays in the system.